Good afternoon, I'm Brian Ballard. I'm with Schneider Electric, and I'm with our rack systems line of business. And that includes things like racks, rack PDUs, containment, pod systems, and things like that. And what we're going to talk to you about today is how can you accelerate IT deployments with rack-ready pod-based designs. So we went out and talked to a bunch of customers and asked them a bunch of questions. And the key thing that they were trying to figure out is there a better way to deploy in the white space? And so we collected a bunch of information, thousands of questions. These are just a handful of them. And then really what we found out was that there were three commonalities between all the types of customers that we talked to. Didn't matter if it was a co-location provider or a government end user account or an enterprise account. They all kind of had the same three things in mind on how they could deploy better in the white space. So the three common points of interest were around increasing the speed of deployment, improving flexibility, and reducing total cost. On the speed of deployment side, it's about the application. So the sooner you can get the application out, the faster you can start generating revenue and getting ROI on your investment. For a co-location provider, it's really about getting that space occupied as quickly as possible, getting the tenant up and running so that you can start collecting rent and getting return on your investment and your operations. When it comes to the flexibility piece, this is where a lot of the challenges come into play. You have a lot of different types of IT systems coming in and out of the white space. You've got life cycles that you're dealing with. You got a lot of adds, moves, and changes. And in some cases, you're dealing with totally different technology platforms like OCP sitting next to traditional IT equipment. And then the last piece is reducing costs. So if you want to be flexible, you need to standardize. But if you have all these different dynamics going on, how do you do that? And so one of the ways you can do that is through a pod-based system design. So let's take a look at the white space and how it kind of operates today. It's really quite complex when you think about it. Take containment, for example, here in this picture. Containment has traditionally been a rack-based design. The rack itself forms the basis of the containment, and everything goes around it. So all the fiber, all the cable, all the power is running across the top of that containment system. And then you bring the IT equipment in, and then you do your rack and stack, your test, provision, and away you go. Now, if you want to do adds, moves, and changes, it's very complicated and almost impossible, essentially, because moving out a fully loaded rack from this containment system that's rack-based, you'd have to move all the cables and the fiber and copper moving on the top of it. So not only difficult and complicated, but also can be dangerous. Moving to a raised floor environment, what initially starts out as a very well-designed, a very well-organized layout of fiber and copper and power quickly becomes very messy and complicated. As you make adds and moves and changes, you're moving things like fiber and copper and power cables to meet the new demand, wherever that is. And then if you're cooling your data center by pushing air through the bottom of the raised floor, these can complicate things by blocking airflow and things like that. Now, we believe that doing power distribution and fiber and cable runs is best done off the ceiling because it gives you more visibility, more access, more flexibility. But even then, if you're doing a change in a live data center, this makes complications for you too because of things like dust and particulate in the air, and you got a bunch of people working in your data center that may not necessarily need to be there. Another thing that customers told us was they're changing the way they deploy IT. So the old method was, I'll deploy at the server level. And that works great for traditional containment and traditional rack and stack. But what they're starting to do, and they're doing more of, is leveraging system integrators to do the build for them, do the test and provision for them, and then bring in fully populated racks in their data center for them. And then what they do is they roll those racks in and plug them and power them up and get them networked. And so really, the compute goes from a use-based decision to a rack-based decision, and by extension, it now goes to a pod-based decision, especially if you're running a data center that's thousands of racks. So that's why we came up with something called HyperPod. It's a freestanding pod-based solution that's rack-ready to roll racks in and out as needed. One of the benefits of this is the flexibility. So because it's a pod-based design and it's freestanding, you can run all your power in advance. You can run all your fiber and your copper in advance as well. And then when you're ready to roll your racks in, you roll them into the rack, you plug it in, and plug in your network, and away you go. As adds, moves, and changes occur, you can roll them out, unplug them, and roll new ones in. So those are some of the advantages of a flexible pod-based design in terms of speed of deployment and flexibility, and reducing your total cost of ownership. Let's talk about the cost and time savings real quick. Now, there's a lot of data and calculations that go behind these numbers, and I encourage you to read our white papers, which explain all the detail. But essentially, the three things you want to focus on here are the reduced ceiling and construction costs. Because the HyperPod has the cantilevers on top, it's running a lot of that equipment for you, a lot of the lines. And you can use things like ladder connectors and things like that to reduce the amount of ceiling grids that you're putting up there. Also, if you're doing a raised floor, well, first of all, you don't need to use a raised floor with HyperPod. You can put it right on the slab, but if you're doing a raised floor, you don't need to do as high of a raised floor, so that reduces cost significantly as well. And then lowering the cost of mounted panels, and that's the remote power panel that I showed you on the previous slide, where we're bringing the power panel to the pod system itself and doing power distribution right at the pod level, as opposed to doing power distribution off a wall and running all the whips to all your racks. Deployment time is shorter and more predictable as well. One of the benefits of the HyperPod is that it's an assembled system, not a constructed system. So instead of having to construct in sequences, you can now construct things in parallel as you do the assembly of the HyperPod. So some of the savings you see are reduced ceiling grid work, all the cable pulls and ladder trays underneath the raised floor. The assembly is quicker on the containment system, and you're also shortening the power whips and all the stuff that's running to power the systems. We have a bunch of resources available to you. Several white papers that explain in more detail how we reach those calculations. We have a reference design for a 5.2 megawatt pod-based build. And then we also have some trade-off tools that allow you to test your designs, do some costing, size structuring, and things like that on pod-based systems, and compare it against other traditional containment systems. So we're over here at booth D9. We've got a HyperPod set up. You're welcome to stop by and kick the tires. And thank you for joining, and good afternoon.